So I was sitting in my shop one day, talking with Jack, my best friend and partner, deciding what we could possibly do with this wood shop to make it profitable, and the best way to utilize our time to learn new skills. Being a new woodworker, I had a lot of skills I needed to pick up quickly, so I wanted to find a way that I could maybe skip a few steps ahead. Having watched a bunch of YouTube videos, I saw some cool things you can do with a CNC machine, and I thought to myself, why do I need to learn all the tricks of the trade with a router by hand if I could just go ahead and have a machine do it all for me? So in all seriousness, this is a 5x10 Avid CNC. We decided to go with this over a standard benchtop model or maybe an X-Carve, something smaller, because everybody that we watched talked about how they wish they would have gone bigger to start with, because once you get familiar with the software, familiar with the workflow, it all gets very simple, very easy, so it's nicer to have a larger platform to work on. You can see the dust hose is hanging down right there. We also opted for the larger spindle, the 8.7 horsepower. We're still working on fitting a dust boot to the spindle. We've got a couple of models we've been working with. Need to make some more adjustments to them to call it finished. If you look here, this is the laptop that we bought to run both VCarve and the Mach 4 software that are required to operate the CNC. Another prerequisite for getting the CNC up and running was we needed a 220 volt 15 amp outlet and 120 volt outlet. Luckily we had the 120 already sitting there. We just put this drywall up a few days prior, so it was kind of painful to cut holes into it. And all we needed to do was add another hole after we pulled the wire down for the 220 volt. We also had to add a double pull breaker to do the 220, but we're marking our holes, and we got this knocked out pretty quickly just with some prior knowledge that we had after making a trip to the store to pick up all the materials. During this time, we also pulled down 2 network cables because we plan to hardwire everything. So if we want to run a project from the house or get it pre-programmed into the system, we can. We wanted one for our laptop and one for the CNC machine, just to set up some basic networking principles. We're hoping to save us some trouble down the road if the Wi-Fi were to go out or anything else. That way we can easily do work from both sides of the shop or from the house and kind of monitor what's going on, even if we're not physically standing in the same room with it. If you look in the image, you'll also see that there's a whip coming out of the 220 outlet. We ordered that with the CNC machine just to make sure that we would have the proper outlet, because I wasn't exactly certain what type they were going to send with it. Alright guys, so as we go into the actual build out of this 5x10 CNC machine, we went ahead and got our tablet out. That's what we used for our instruction manual. We downloaded the instructions off the Avid website, took a tape measure, laid out our 5x10 dimensions, even though the machine takes up just a little bit more space than the 5x10, pre-opened all of our boxes, cut out all the packing material, and then neatly laid everything out based on the packing instructions so that we could make sure that we would have easy availability to it all, and that we had all of our materials. It comes with a grease gun that we can keep all your fittings greased up. Everything should stay nice and lubed, that way you're not, binding up any gears. We also went ahead and pulled out some levels. We pulled out our Husky rolling toolbox, which has all of our standard generic tools, and I guess metric tools to go with it. We wanted just to make sure that we had everything on hand. There's a solid list of items that you're going to need in the beginning of the manual. That way if you need to run to the store like I did to get an 8mm wrench, you're able to. Just make sure you've got everything on the list. Some stuff you don't need, other things might make the job easier. A lot of the videos you see on how to build this out, they use drills for everything. We used Allen wrenches on all. We didn't have any ball end Allen wrenches, and that's what they recommend you use, and that's exactly what we did. We do end up breaking in one of the ball ends because we're over tightening something, so I don't know if that's the recommendation of why we used it, but that's why we went and bought them, just so we would have everything we would need. We wanted T-handles, couldn't find T-handles, so just went with the standard setup. The drills were there because, again, we saw the videos where people were using drills, and we thought, well, maybe that would speed the process up. But I've always come from a mechanical background with the Air Force, working on aircraft, and you never want to over-torque anything, and that's kind of the mindset I had going into this project. I didn't want to break any bolts, and I didn't want to over-tighten anything, causing issues down the road. The levels, that's the largest level I have. I wish I had one that was a little bit longer, or a string level. And then, of course, we've got some clamps. We've got 2 24-inch clamps and then 2 smaller ones. They came in handy with holding things together to make sure we get them nice and tight and square. One of the only mistakes we made in this project are attaching the feet. The plates go in a certain orientation and direction. Everything does come pre-threaded, so you don't have to try to thread anything with a bolt or have a tap and die set. Just a heads up, I did try to force some bolts in here. I was able to get them halfway in before I realized that I was making a mistake. So just flip the leg around and attach the foot to the other side if you're messing with the side that doesn't have any threads on it. So at this point we've got about half the frame put together. It came with these T-slot brackets That's what's going to hold both halves of it together. We went ahead and wanted to square everything up as much as we could and level it out as much as possible as we went into it, tightening down the bolts enough to keep it a little past snug, but still adjustable. Alright, so following instructions, we went ahead and put the arms on. They didn't have us put the legs on first, which I thought was a little strange, but it does show the strength of the materials that they're using for this build out. And you can see Jack just posted up in his usual position, watching all the work as it happens to make sure we don't make any more mistakes. So here we are several hours into the build, probably about to call it a day because it was getting pretty late at night. And we noticed that once we finished the assembly, we're missing some of the leg gussets, which are the angled brackets I'm pointing at in the video. We needed 4 more. The reason we were missing those was a mistake on Avid's part. They did a extra leg kit after the fact just to give the table more stability, and when I ordered those extra leg kits, they did not get processed properly to give us enough gussets to put the legs on. So I kind of spaced them out just to make sure we could finish the build, leave stability, and Avid worked with me and got them sent out the following week, and we got everything attached properly. So this is where we start putting on the tread assemblies on each rail. This is basically what is going to move the spindle itself up and down the axis on the long side. So if you look down at it, you can see where it just slides into place with the bolts that they send you. It's a pretty neat system. Makes it really easy to do this by yourself with just one person. Obviously having 2 would be a little bit easier, as it'd be easier to balance it out, to slide it in without it binding up at all. But I didn't have too much trouble doing it on my own. Here we're using the clamps to hold the gear slots together. That's the way they recommend doing it in the instructions. That way you can keep everything nice and tight, and it should help your teeth keep from binding up later because you've got to pull together as closely as you can. And then it's at this point that you come back with your ratchet and tighten everything down. Some people recommend using drills. So this is where I noticed my camera was starting to have issues. It was eating some of the memory cards. We were able to get some of the footage back, but we did not get the overall footage. So as you can look in the video, we've already put on the end caps, the red stop plates. That's what it uses with a sensor to tell if it's hit the safety stops or not, or the limit switches. We also put the black plastics over the top of the rails. That helps keep dust out of them. That way, as it's running back and forth with the glides, that put out the lubricant to keep everything nice and mobile. We also went ahead and put on the motors. We've already got the crossbar on, so I apologize for losing that footage. We've corrected that issue since. We also went ahead and started putting on the tracks, as you'll see in the video. We also put the cable rack on. The cable rack kind of helps protect your wires and make sure they move in motion with the machine without, spreading out and getting bound up on anything or caught. This is probably 1 to 2 days after we did the other work. We just didn't have time to get back to it, so definitely having all the instructions around with us to make sure we're getting everything in the right orientation and the right spots while using the correct screws. So now we're going to start putting on the cable track system for the upper bar. What you will notice is there's a little bit of rust that's already started to form just in a matter of days on top of this gear track that runs back and forth that the motor uses to push itself along. We're going to have to do something in the shop, as you guys have already seen in my other videos, for the humidity. I just don't have any way to control it yet. Just a very difficult thing to do in the southeast unless you put a full HVAC system into your building. If I ever do build my own shop, that'll definitely be something I do. For now, we're just going to try to get some dehumidification in there. And if you look at the box in the background, I do have a split unit that I plan to put in to help out in the summertime. Just whenever it gets too hot, too cold, hopefully it'll balance it out a little bit better and keep these things from happening, because we definitely don't want to mess up our brand new, very expensive tools. I was getting pretty tired at this point, and you'll watch me put the T-bracket in and then make a face because I let it slide down the track. And now I've got to figure out a way to get it out of the track because the boater won't let my fingers get in there. And my finger's a little bit too big to slide in those slots anyway. So we have to run back to the toolbox, try to get it out with just a standard magnet. Didn't work. Now we're having to sit there and think about what else we're going to do. Luckily for us, we came from an industry where we have all kinds of tricks of the trade. So we have a flexible magnet now instead of a iron rod magnet that's on the end that doesn't get as flexible or as thin. This one would actually fit in there so we could get the piece out. And then we're going to throw up some hand signs as we look around trying to find a screwdriver or something else to hold it in place with. Working in the middle of the night definitely makes things pretty difficult. And now we're trying to line everything up. We'll grab a tape measure once we get everything put in there. These T-bracket slots that they, or nuts that they use are kind of springy on the back. In most cases, they hold themselves in place. But on the upper piece that we're working on now, they always slide down. You know, gravity works its magic. So just be prepared for that when you go to put the screws in. Definitely a little bit time consuming, and if you're working in the middle of the night like me, after working all day in the heat, it's just a little, cherry on top of an already rough day to try to dig those out. So this is where we finally start seeing the light at the end of the tunnel. We've got the control wiring and everything pulled out of the box, getting ready to lay it out in the cable tracks and attach it to the equipment. We also go ahead and we pull out the control boxes themselves, just so we can see what they look like, make sure nothing else is left on the bottom of the box, as we try to get everything neatly organized and ready for the final push. This is definitely a project you can knock out in 2 days. It might be a long 2 days if you're by yourself, or if you're new to doing this kind of work, maybe it'll take 3 or 4 days, but I was able to do it in 2 without too much issue. Alright, so this is a limit switch that is made for the equipment. The wires go directly into it. It screws directly into the side of the equipment. There's several of them around it, one for each axis. That way it knows where the set limits are. So these limit switches basically protect it from grinding against itself if it were to hit the physical stops. The physical stops do have rubber bumpers there, but you definitely don't want your motors driving against them. And these are the pieces of equipment that allow the machine to know where it's at if it gets too close to hitting those. Once you get into Mach 4 software, you can do a auto run that sets the limits and it'll set all the stuff up for itself, but you do have a manual that tells you exactly how far out it wants all of the individual stops to be and exactly where it wants these limit switches placed to make sure that you're not going to overdrive anything in one direction. Now that we've completed putting the base together and getting all the equipment together and the spindle on, I went ahead and put my makeshift dust boot on. Definitely needs some work. We haven't finished it quite yet, but we had the hose held to it, picking up some of the dust, not quite all. If you look at this image, you'll see in the upper left-hand corner, there's an extra hole, and these holes are the mounting slots. They line with the cross braces. That way you can put a T-nut through and a screw, and it attaches the board to the base and keeps everything nice and firm. Like I said, we cut everything extremely accurately on these pieces of plywood to make sure they would fit in there nice and snug. So technically I could probably leave those T-slot nuts out, but went ahead and did it anyway just to make sure everything never moves, not until we're ready to replace the spoil board. But that extra hole up there is one of the mistakes I made. Somehow I had the initial run offset, noticed it on the first hole, let it finish cutting the first hole, and then reset the program. Don't know how I fixed it. All I did was start it from scratch again. If you look at the video now though, we got lucky and it lined up perfectly with the clamp slots. So you can't even see the hole now. It looks like a completely properly done fresh table without having to replace the plywood, which would have been detrimental considering how expensive wood still is even right now. Alright guys, so I'd like to do a shout out real quick to Andy Bird Builds. I did pay for this project that I'm doing now to get the information on how he did it. But if you guys could, check out his channel. He's got some really good content and typically puts out videos pretty consistently with his CNC work. So right now what we're doing is we pre-painted this board, let it dry for 24 hours, and now we're taping it up because I wanted to see if this would be a quicker means of painting these Santa trays that we're trying to make for Christmas. So we already pre-cut one just to test out with some scrap MDF we had sitting around, and you can see that in the image clamped down to our left. And that's just standard painter's tape we're putting down because I felt that would be gentle enough on the paint not to mar it, not to scratch it, and let it keep that nice pristine candy apple red. As you can see, the clamp slots work pretty well for us to keep everything to the table. There's also a slight groove. You can't see it with this camera, but there's a slight groove in the table that we can butt up against with the board, and that just helps us make sure that everything's nice and square. And I struggle a little bit to get under here, so I've got to find a better way to clamp this down. Haven't decided exactly what I'm going to do yet. I've seen some really good options. You know, if I had the money, I'd do a vacuum table. So right now we're using the auto touch pad that you can pay a little bit extra for. I definitely recommend it. You just has a little magnet on it. Put it on the edge of the router bit, and then let it touch the touch plate, which has spring loaded, and that automatically configures the machine to be in the right orientation for whenever it starts to do the cut, as you'll see going forward. What it does is verifies each axis, up, down, left, right, just to make sure it's getting the right place. One thing you will notice is there is a little bit of tear out that happens. Again, this is MDF that we're cutting into. Andy was using hardwood in his video. I couldn't get my hands on any for it, but we wanted to go ahead and try to make MDF work anyway, just because we had some of it on hand. But the E's, the A's, the finer details are just getting kind of tossed out on the little centerpieces that just break away. Don't think that's going to be a problem with hardwood, but we'll try that once we get our hands on some black walnut that we're expecting in the next couple of weeks. Now we pulled it off the CNC machine, and you can see where some of the tape got removed. Some of the finer details got tore out, and it just seems like it wasn't the greatest idea the way that I was trying to do it. But we definitely want to find a way to make this workflow as quick and easy as possible. I also next time would have used a bit and let the bit itself cut out the exterior of the board. Instead, you could take it to a bandsaw, jigsaw. I ended up using my circular saw because it's all I had at the time, and just trim the edges off. But the CNC machine can definitely do that with a larger bit. So this is where we went back with some white spray paint and tried to get it to fill in the gaps, peeled off the tape, and you can see where it didn't work out perfectly well like we wanted to. Definitely needed more coats of it. The biggest problem and issue that we saw with this test run is it's leaving the residue from the tape and the tape lines inside the tray itself, and that was one thing we didn't want to happen. The other completed project we have is a doghouse that I made for Jack, since we're getting into the colder months now, and I just wanted to test out the lettering to see how that would work on the machine. I got a 1/8 inch bit with a 1/4 inch shank, and that's what we're using here now, and this is a piece of Baltic birch plywood that we just had left over. The bit's getting a little hot cutting it, but definitely it's going through it without much of a problem at all. We didn't get any breakaway or chip away that we weren't expecting, other than the fact that it's plywood, so it does bust out a little bit, but the lettering itself looks pretty good. And I'll throw an image up here real quick of what the finished product looks like with the doghouse. If you guys watch my shorts, you've already seen it, so definitely feel free to drop out here. And this is the last part of the video. If you guys liked any of this content, if there's anything I can do to improve, just leave a comment below, leave a like. I'm definitely trying to respond back to everybody and trying to make this channel as good as I can over time, and trying to get better at the video editing. So sorry if it's not great yet and still a little rough around the edges. And thank you guys for all your support. I definitely appreciate it.